In this video, I'm going to solve a sample problem about virtual work method applied in determinate truss. Here's the problem. Use the virtual work method to determine the horizontal and vertical components of the deflection at joint B of the truss shown. So first is solve for the reactions. So determine the reactions at the supports. Joint A, the support is a roller, so the reaction is perpendicular sa surface. So and compression siya. So the direction is towards the right. For joint D, the support is a hinge. So there are two components, horizontal and vertical. So when you solve for the reactions, you can start with summation of moment about D so that you can solve for RA. That's the usual practice. But by inspection, there's only one unknown vertical force na unknown. So you can just sum up force vertical. So summation of force along Y or vertical equal to 0 and upward force is positive. So the equation is this. R dy minus 20 kips minus 40 kips equal to 0. So transpose all the constants to the right side. R dy is equal to 60 kips. Since positive, therefore upwards. So next is to solve for RA or RDX. So we sum up moment about joint D. And we can solve for the reaction at A. Counterclockwise movement, positive. So here's the equation. RA force times distance 10, counterclockwise so positive, minus 20 force times distance 10, clockwise so negative. 40 kips also clockwise so negative. Force, the distance is 20. So constants, it transpose the right side, and then after that, the result divided by 10, then you can solve for RA. RA is positive 100K, therefore, the assumption is correct. The direction is to the right, kay positive man. And to solve for RDX, you sum up force sa horizontal. Okay, force directed to the right, positive. So RDX plus RA, which is 100, equal to 0. So RDX is equal to negative 100. So negative, therefore, the assumed direction to the right is wrong. So the correct direction of RDX is left. So 100K or 100 kips directed to the left. Okay. Next one is to determine the bar force of members due to real loads. Sa formula sa virtual work, it is denoted by capital N. Okay. So, due to real loads. Okay. So we have the reactions 100, 100, and upward of 60. So you solve for the forces or force of members using method of joints. So you start at the joint having two unknown forces. You can start at joint D or joint B. Okay, let us start at joint B. So at joint B, okay, here's the joint. And then we have this external force or load 40 downward. And sa usual practice, pag unknown ang force, assume it na tension siya. So, for force BA, to the left, no, kay tension. Assumption man na. So that every time mag-negative ang value, you just conclude na compression siya. Okay. BC, second quadrant. Okay. Next is, instead of using angles, to avoid rounding off errors, you just use slope for this line. So, ang slope in the line is vertical is to horizontal. That's 10 over 20. So, in lowest term, that's 1:2. So, muna ang slope anin. 1:2. So, by Pythagorean theorem, the hypotenuse is square root of 5. Sa slope lang ha. So, we're going to apply this one or to use this one sa BC. Okay, so you have two unknowns. You can start using the conditions of equilibrium. First, summation of force sa horizontal equal to 0. Positive, going to the right, positive. And FBA is directed to the left. The horizontal component of BC is also directed to the left. So they are all negative. Okay. For FBC, the horizontal component is this one. 2 over hypotenuse. Horizontal man. So 2 over hypotenuse, square root of 5. Since we still have two unknowns, let's denote this one as equation 1. Next, summation of force Y. Upward force, positive. So the vertical component of BC is upward. So plus and then 40 minus. Okay, transpose 40 and then multiply it by square root of 5. That's FBC. Positive siya, so therefore tension. So after this, you substitute this value sa equation 1. So 40 square root of 5, substitute ni mo dire. 40 square root of 5 times 2 over square root of 5. The result is negative 80. So when you transpose FBA sa right side to become positive, the left side is still negative. Negative 80. Therefore, if BA is negative 80 or compression since negative man. So conclusion, if BC is 80 keeps compression. Okay. So we have solved two members. Next, we proceed to any of the remaining joints since there are only two unknowns for each joint. Like for joint C, BC or CB is already known. So we only have CD and CA. So joint A, we only have two unknowns, ED and EC. Since AB is already known. Or joint D. Okay. The more convenient joint is joint D. Since the other forces are either horizontal or vertical. No need to get components. So let's analyze or let's consider joint D. So sa joint D, the forces are reactions on 100 directed to the left, 60 directed upward, and two unknown forces. Again, as a practice, pag unknown, assume it na tension. So, FDA tension, FDC tension also. And we use the same slope sa BC. And then use conditions of equilibrium. You sum up force sa horizontal. We only have two forces, component of FDC and 100. And transpose 100 and then divide it by 2 over square root of 5. The answer is this one. Since positive, therefore tension. Next, you solve for FDA. You sum up force vertical. We have three forces, 60, FDA, and the vertical component of DC. And since we already have the value of the FDC, we can substitute it here. So we can solve for FDA. And after you simplify, FDA is positive 10. Therefore, it's tension. Okay, so the last member is easy. So you can either analyze joint A or joint C. Okay, let's analyze joint A. So at joint A, this is joint A, the forces are 100. And then this one, FAB, already known. We solved it earlier. And also this one, FED, 10. And then AB is ET. Okay. So, the only unknown is EC. So, since unknown siya, i-assume na to na tension. The same slope. 1:2. Kay 5 man. 5/10 is 1:2. Since we only have one unknown, you can use either of the two conditions. You can sum of force sa horizontal or vertical. Okay, let's try this one. Summation of force sa Y. We only have two forces, 10 and the vertical component of FEC. And transpose 10, that becomes negative. So FEC is negative or compression. Okay, 10 square root of 5 compression. So we are finished with the bar force of members due to real loads. Okay. Next is to determine the force of members due to a vertical load. Now, since the problem is asking for the horizontal and vertical deflection at B, first let us consider a vertical unit load at B so that we can determine the vertical deflection. Okay. Remove all real loads and then we apply a vertical unit load at B. Okay. Let's assume na downward, 1.0. And again, you solve for the reaction first before solving for the members. RA, RDX, RDY. And then you start with summation of force of vertical, since we only have one unknown vertical force. RDY minus 1. So transpose, RDY is positive, therefore the assumed direction is correct, upward. Next, summation of moment about D. We can solve for RA. So RA times distance minus 1 times distance. So RA is positive 2. So the direction, the assumed direction is correct also, to the right. And last, to solve for RDX, we sum for sa horizontal. RDX plus RA, which is 2. RDX is negative 2. Therefore, wrong ang assumption na to. The final direction of RDX is to the left. Okay, so with the known reactions, we can now solve for the bar force of the members using method of joints. We denote it as small n. Okay. Force of members due to a vertical load. So the reactions are this one, two to the left and 1 upward. And same with the real loads, we start at joint B and then we jump to joint D and then next is joint A. So joint B, 1 downward, unknown if BA, unknown if BC. Same slope, huh? And as usual, you start with, or we use the conditions of equilibrium. So we sum up for sa horizontal, two unknown forces, all negative, directly to the left. So since we have two unknowns, let's denote it as equation 1. And then summation of force of y, two forces, vertical component of BC and the vertical load. So transpose 1 sa right side. Then if BC is positive, so tension siya, square root of 5. Next, we go back to equation 1 and we substitute if BC, square root of 5, and then transpose if BA. The result is negative 2. Huh? Square root of 5 times 2 over square root of 5, that's 2. Negative 2. So you transpose ang FBA to become positive. It is equal to negative 2. Therefore, FBA is compression. 2 compression. Next, joint D. So for joint D, we have the reactions 2 to the left, 1 upward, unknown DA, FDA, and unknown FDC. The same slope. So we sum up for sa horizontal, we only have one unknown, FDC. Transpose 2 sa right side, that becomes positive. So therefore, FDC is positive. Okay, square root of 5. Next, sum up force sa vertical. 3 forces, 1 FDA, and the vertical component of FDC. Since we already have the value of FDC, we're going to substitute this one sa equation, FDC. Square root of 5 times 1 over square root of 5, 1. Yeah? 1 minus 1, 0. Therefore, FDA is equal to 0. Okay. And the last one is at joint A. Joint A, no? We have the reaction 2 to the right. And then FED, which is 0. And then FAB, which is 2 compression. And then unknown force, FEC. Same slope. And then use any of the two conditions. Summation of force X or summation of force Y equal to 0. So, okay. Let's sum up force vertical. Now, since 0 ang FAD, we only have one force, the vertical component of FEC. So, by inspection, FEC is equal to 0. Okay, so after this, we summarize all values by constructing a table. Okay, so sa table, identify all the members, joint A, AB, EC, ED, joint B, BC, joint CCD. And then N, force of members due to vertical load, capital N, force of members due to real loads, L, length of the member, A, cross-sectional area, which is already given. Given, and also E, given sa 10,000 KSI. So, we fill up this one with values of N. Okay, EB, 2 compression, so negative siya. Negative. EC, EC, ED. AC is 0, ED is 0, said 0, 0. And then BC and CD. BC is square root of 5. CD is square root of 5 also. And the next, force of members due to real loads. Okay, EB, ET keeps compression, so negative. EC, EC, no? This one, EC. 10 square root of 5, negative. ED, ED. 10, tension, positive. BC, 40 square root of 5, positive. CD, 50 square root of 5. So, 40 square root of 5, 50 square root of 5. For L, in inches. So, EB, the length of EB is, 20 feet. So, 20 feet converted to inches times 12, that's 240. You do the same for the other members, no? Okay. So, we can solve for the length of EC, BC, and CD using Pythagorean theorem. Square root of 10 squared plus 5 squared. That's the length of EC. Okay, converted to inches na. Converted to inches. So, final step is to determine the values of this one. Formula for the virtual work method. Small n times capital N times L over EE. So, force of member due to virtual load, force of member due to real load, length of member, cross-sectional area, modulus of elasticity. So, we multiply small n, capital N, and L. I-multiply natin eh. Negative 2 times negative 80 times 240. And then the value i-divide sa product of A and E. So we multiply 8 and 10,000. So this one divided by this value, the answer is 0.48. Positive, no? Negative, negative. Positives. For EC, si 0 man eh. So 0 eh. For ED, 0 sa dang N. So 0. For BC, this one, square root of 5 times this one divided by 8 times 10,000. This is the result. And then also for CD. And the final value is sum up. Summation of n times L over EE. So add all values. Okay. If positive, it means na the displacement is in the same direction of the unit load. So the assumed direction is downward man. Downward ang unit load. Downward. So pag positive ni, which is obvious, positive, so it means na downward ang displacement sa vertical displacement sa joint B. Kaya nag-positive man. So the assumed direction is correct. Okay. Next is for horizontal deflection at B. So in order to determine the horizontal deflection, we apply a horizontal unit load at joint B. Okay, this is our truss. We apply a horizontal unit load at B. Let's assume na right siya. Okay. Right. If positive, then we are correct. If negative, then it means na the horizontal displacement of B is to the left. Kaya nag-negative. Okay, so we start with reactions RA, RDX, RDY. By summing up force of vertical, we only have one vertical force. So it means na RDY is equal to 0. Wala man mag-balance. So RDY is 0. Okay. Next, summation of moment about D. Here, no? We can solve for RA. RA times 10 plus 1 times 10. Therefore, RA is negative 1. It means na the direction of RA is to the left. Because the assumed direction is right man. Tapos nag-negative, therefore left. And then last, summation of force X. Okay, so RDX, right, RA, right, 1, right. All of them going to the right, no? But RA is negative 1 man. So makancel ne. Therefore, RDX is equal to 0. Okay. Since we are finished with the bar force of members, the force of members due to real loads, our concern now is the small n, force of members due to the virtual load. Okay. So, this one, horizontal load at B. So, reaction, negative 1 or directed to the left. RDX 0, RDY 0. Okay, so we start with joint B. So, force, and then FBA, assume nga tension, same slope, and then we apply conditions of equilibrium. Summation of force along X. 3 forces, no? Horizontal component of FBC, FBA, and then 1. 2 unknown forces, so let's denote this one as equation 1. And then next, summation of force Y. We only have one force, vertical component of FBC. So therefore, FBC is 0. So, pag 0 ang FBC, substitute sa equation 1. From equation 1, FBC is 0. 0 na. So what remains is 1 minus FBA. So transpose FBA, positive siya. Positive 1. Or simply, tension. Okay. Positive man. Next is joint D. 0 ang horizontal and vertical component sa reaction. 2 unknown forces. Now, if we sum a force sa horizontal, no other force will balance this one. Horizontal component of FDC. Isa lang man. So therefore, FDC is 0. Next, summation of force sa vertical. Okay. And 0, 0 sa dang FDC. Although negative siya downward, but since 0 siya, therefore FDA is 0 also. And then the last member is EC. So we consider joint A. So at A, we have the reaction 1 directed to the left. EB is 1, tension. And then ang ED 0. Here is EB 1, tension. And then unknown force EC. So again, since last member, you can use any of the conditions. Summation of force X or Y. Okay, let's use this one. Summation of force Y or vertical equal to 0. 0 man. So no other force will balance FEC, vertical component. So therefore FEC is equal to 0. So 0 ang 4 forces. The only member with a value is BA or EB. Okay, so summarize again the values. Construct a table and then supply the values of N. BA only has a numerical value +1, the rest 0. So +1, the rest is 0. For n, we have solved this one. No? Sa vertical, same lang. So, wait. Okay. So, this is for the virtual load. Okay, same value sa real loads. And then for the length, same also. Okay, same lang. So, next is, get the value of this one. So, we multiply small n, capital N, and L, and then divide it by the product of A and E. Negative 0.24. The rest is 0 kay 0 ang n man. So 0, 0. So if we sum up, the result is negative. So it means na the horizontal displacement of B is to the left since nag-negative siya. Okay. So this is how you are going to use virtual work method in determinate trusses. I hope that you have learned something from this presentation. Thank you for watching.